All right, well, if we're going to get started, I guess thanks everyone for joining us over the lunch hour. Appreciate that. I was going to say, hopefully you have a nice lunch to enjoy while we're doing this, but actually, ideally, it's not quite so perfect because then I have to compete for attention with a lunch, and that might not work in my favor. But anyways, my name is Stuart Schindel, and I am the CEO and owner of Rammed Earth Artisan, REA, Rammed Earth Artisan Limited, Inc., to be technical about it. Thanks, Kim, for inviting me to speak today. And I guess since time is of the essence, I'm just going to go into sharing my screen here and get right to it. So kind of this goal of this talk is just kind of introduce everyone to Rammed Earth in general, then breaking off into some specifics for Passive House and hopefully get people interested and seeing the potential for Rammed Earth in a Passive House context. We'll go take a look at the agenda here kind of just quickly. I've got a couple of chapters here to go through here, but it's hopefully we can go through them fairly quickly. All right, so we're going to go through the who, what, why, Passive House around Earth, the process, pricing a little bit, goals, and some pictures, and might as well just jump right in. So I guess start things off with taking a quick look at the company just to get you familiar. Start with the mission statement, and the mission statement is basically creating beautiful high performance structures using sustainable materials. I would imagine that would resonate with most people in the Passive House movement because that's kind of what you guys are about, high performance structures. So hopefully I can show you that Rammed Earth should be a consideration to achieve those goals. So my name's Stuart, I mentioned. I like to call myself the chief dirtologist. That's a very technical term that I just kind of made up on the fly. From an energy efficiency and sustainability standpoint, I basically just want to see people living and working in high performance buildings, which I assume we share a common interest there. And because we spend so much time indoors, I also think it's important that these homes be healthy, non-toxic materials, kind of nice enriching environment, which Rammed Earth covers. I look at every wall basically as a functional work of art. So it's dual purpose for me. I get a lot of joy out of the artistic side, but also knowing that I'm creating a high performance, sustainable wall that's going to last for generations. I guess it's one thing to be good at doing what you do, the trade, the craft, but it's another thing to run the business properly. So to make sure that's going to happen for me, I partnered up with a group of business owners, accountants, business developments, licensed financial professionals, and other construction industry professionals that have a proven track record to hopefully help me develop this in the right way forward. So that's where the rest of my business team comes into this operation. As far as the day-to-day Rammed Earth stuff, that's me kind of as the main guy there. And we are based in Saskatchewan, but we have been fairly active in Western Canada, even Eastern Canada on occasion. And so, given the right project and the right circumstances, we'll consider other locations as they present themselves. So moving on to the what is Rammed Earth. So we'll start off with just a simple and basic definition. It's an earthen building technique where we're compressing layers of dampened earth mix or soil mix into formwork. It's really that simple. Repeat the process till you reach the full height of wall. Obviously, in the modern world, we've got to take things a little bit more seriously than that, but there are codes and sort of things like that. But that's the overall gist of it. And if we look at this picture here, they're just literally ramming on-site high clay subsoil into a form, and that's done. They're doing slip forming. They're just going to repeat the process over and over and over. Now we're going to look at the modern world of Rammed Earth, where we get to stabilized Rammed Earth. Now there's a bit of a contention there. In Europe, they're still able to build raw without cement stabilization. So they kind of look down their noses at us for putting cement into the mix, and basically all our eco-credential points go out of the window according to them. But I mean, good luck building in North America without stabilizing. They're just not going to let us build that way in North America. So we use stabilization, cement, sometimes lime and metakaolin clay, and that'll help reduce the cement content. We got a sandwiched wall with insulation in the middle. You can see a little bit in the picture here. If you look, I'm just going to look over my screen here. You can see insulation exposed there. That's where conventional building wall is going to butt up against that, and they'll carry the insulation through to the rammed earth wall to get a continuous envelope. Reinforcement, pretty simple. Steel rebar or other composite rebar materials is also a possibility. So you basically end up with a structural load-bearing wall, 2 wives, insulation and reinforcement. It's a dense, highly water-resistant sandstone-like wall, basically, and it's got the durability of concrete and, I like to say, the beauty and texture of nature's sandstone. So I often look at the sandstone pictures that I can see on the internet and in books and stuff, and try and take some inspiration from that to try and do a little biomimicry where possible. Break it down here to a rammed earth wall section. You can see all the various parts. We got the inner and outer wive, some rebar reinforcement, insulation. You can see the recessed, look over here, recessed electrical box over there, conduit running through the top. I'll get into more details of this as we proceed along the procedure, but hopefully that gives you a good idea of the wall system there. So here we're looking at a rammed earth mix, and rammed earth is actually usually referred to as both a material and a process. So from a material standpoint, looking at aggregates, cement or other stabilizers, iron oxides and pigments to control the aesthetic, add a hydrophobic admixture. It's a non-toxic silicone emulsion that makes the walls integrally waterproof and reduces, efflorescence and other problems. It also strengthens the mix, which is nice. And then just a minimal amount of water, like it's a very, very dry mix. And then just because I'm talking to Alberta here, I figured I'd go back in time 8 or 9 years and make sure that that pile of dirt looked like the Three Sisters, so I could draw on this later. I thought that was kind of neat. I know most of you are probably familiar with that mountain range. That's one of my favorites when I drive out in the area. A little bit more about the materials. As far as aggregates, the romantic ideal is that you're digging on site and using the material on site, and it's a closed loop system. The reality is that's almost not ever feasible or beneficial in the long run. So we use local road-based gravel from the local rock quarries or sand pits. Sometimes we'll find even private owners with aggregate yards that we can get what we need from them, but we try and stay very local as much as possible to reduce, mileage and transport and that sort of thing. Cement is going to be anywhere from 4 to 10% of the mix. And we basically have a mix design process where we test for those exact ratios that's going to, meet the engineering requirements, what the engineer's speccing for the project, as well as meeting the aesthetic and texture goals that the client and the design team wants to see. I have a picture at the end of the presentation. I know that I can just kind of show the difference of textures that you can get depending on the different ratios. So we'll take a look at that later. What else do we got in that mix? Concrete oxides. Like I said, that controls the palette. So I can create it as natural and mute as you want to mimic the local geology, if that's what you want, or I can get wildly flamboyant and crazy, as you'll see through some of my pictures. I've kind of almost got a split personality when it comes to rammed earth. There's part of me that just wants to do these natural building materials and keep things looking as nice as normal, or I guess not normal, but as natural and environmental as possible. And then there's other parts of me that found some artistic talent, and I kind of get a little bit overzealous and crazy. So from a designing standpoint, that's kind of nice that I can offer basically whatever you want. And if you can communicate what you want, I can probably mimic it in the rammed earth wall. I already talked a bit about the admixture for waterproofing, and then a minimal amount of water. And when I say minimal, I mean so little that we keep the aggregate piles tarped on the site. If it rains for more than about a minute, it's a mad dash. Everything stops. Cover the piles. You don't want any moisture in the mix because that can literally stop production. And to the point where I was going to tell a little story here, where I was working on a project in BC quite a few years ago, and our aggregate pile got rained on, and we were like, last day, needed to get the job finished, but the mix was too wet. It was just going to look, we were doing infill walls, so they had to match the other aesthetic of the house, and the mix was wet. So I'm just going to bring up this. Here's Laurel, one of the homeowners. We've got the mix spread out on the pad, and she's out there with a tiger torch drying out the pad. So, she spent a couple hours out there drying out the mix enough so that we could use it for the day. So I think we lost some of the eco points for the day, but we got the job completed. So kind of a win. I'll take it. But yeah, you don't want to do that. You want to keep the mix tarped and dry. That's how dry our mix is. So now we're going more into the system of rammed earth, the process of rammed earth. This will show you kind of a 2D sketch here. Many others that when they do rammed earth, they're using the standard concrete formwork systems, which involves a lot of through ties and seams. But for better or worse, I am a finishing carpenter previously to this, and I just can't stand seams. I don't like through ties. I'm looking to get as pristine, seamless form or off the form finish as I possibly can. When we're building it, I'm always joking, we're not building a piano, but maybe try to, I look at my formwork with quite an intense eye for detail. We use paper-faced form ply and lumber, dimensional lumber, often for our forms, and it's all reusable multiple times or even in the project. So it's a pretty good system that allows us to get a really premium product when we take the forms off. I like to say there's a reason that artisan is in our name and not just builder. So you can see, you got the formwork there, whalers for support. After the formwork is up and built, we'll throw the mix in. Mixing is generally done by a mixing bucket, or some people will mix just the skid steer on the pad. I don't like to do that, not quite as much quality control. I've gone past that now to just always using a mixing machine. Delivered into the form first via many ways. We can shovel it, we can blow it in through a hose, use conveyors, buckets, whatever it takes to get the mix in the hole. And then some guy jumps in there on a pneumatically powered tamper, which is essentially an air-powered pogo stick, if you will. And they just compact 8 to 10 inches of earth mix down into about a 6 to 8 inch lift, a nice consistent density that will give you basically a sandstone wall. It literally comes out with about the same density as natural sandstone. Inside that form, they're navigating insulation and a rebar grid, but our rebar is significantly less than a concrete wall. It's not terrible, but it's a pretty fun process. If you're ever looking for something to do and I'm building a wall, feel free to reach out because I can always use other people to navigate the walls. So here's just some pictures. You can see formwork going up, scaffolding. There's that mix pile again. We got a skid steer mixer on the bottom left corner, and then just a couple of different delivery methods. You can see on the right corner there, you'll see the big house I did that comes up over and over again in the slides here. That was all delivered shovelfuls at a time, just building layers, shovelful after shovelful after shovelful. So it's a fairly labor intensive process, to say the least. When I can, I'm using conveyors, as you can see, either just to the mix or just to the scaffold or right into the form, depending on the project. Now you can see me going in there and ramming the walls. You can see the wall composition there. You got rebar horizontally. You got withe ties basically locking in the two inner and outer sides of the wall together. Insulation in the middle. Then you got the finished wall there at the top of the form. We use a high concrete content cement cap on the top just to tie everything together. There's a bit of a rebar bond beam detail in there with the rebar up there. You can put roof anchors in there if you need to lock your roof down, or however you want to fix the roofing members, trusses, that sort of thing. And then when you strip it, you get that nice pretty wall there. Theoretically, rammed earth is stabilized in two ways: chemically by the cement, as well as mechanically via the actual compaction process. So some builders will actually slip form and they'll release the forms like immediately after it's done and keep climbing the wall that way. Again, that adds sort of seam lines and not cold joints, but lift joints that I don't really like. So we like to leave the forms on for 12 to 48 hours, usually at least till the next morning before we reveal our masterpiece. So we'll start talking about some of the technical details. We got the density coming in, like I said, around sandstone, 2,000 to 2,500 kilograms per meter cube are sort of the ranges that I generally see. To be honest, it doesn't matter what mix I use. I always seem to be in the 2,400 round or 2,400 realm. So I guess that's consistent at least, but I always strive to be plus 2,000. RSI. So this is when I'm talking about the RSI here, I'm talking about per inch of the earth. So not the added insulation. So rammed earth is actually quite a poor insulator. It's a good thermal mass, but it's a poor insulator. So I've seen people claim R1 per inch, but realistically, I think 0.4 is about the most realistic and conservative or accurate value to throw at your insulation calculations. Compressive strength, again, there's all kind of variations. A lot of stuff I see in the southern states and even in Australia, they're talking about spec to a minimum of 2 megapascals, which theoretically, I guess, is strong enough, but I've never had a project spec under 10 MPa by an engineer. That's been the lowest. Usually it's 12 to 15 MPa, 20 MPa for more critical spots like lintels and larger spans. If it's an elevator shaft, I think it was spec'd at 25, maybe even 30. No, I think it was 25 for an elevator shaft. But so generally speaking, on a personal note, I'm shooting for 15 because I know it's strong enough to meet just about everything, but it's not getting too crazy, which involves, more cement in the mix. I'm trying to always keep the cement to the minimum, so it becomes part of the mix design process I go through to meet what the engineers want to see, but also try and keep the cement content to a minimum for obvious reasons. I've seen and heard of people achieving 36 MPa and even higher, and that's certainly possible, but I haven't been called to build a rammed earth bridge or overpass, so I can't imagine why they need to be reaching that. I think it becomes almost kind of like a peeing match, we'll call it, where people are trying to just claim the highest MPAs, but really all they're doing is throwing 10, 12, 15% cement, and at that point, it's pretty much concrete. And through the process, we're always ramming test cylinders and getting them laboratory tested, brakes just like a concrete. I believe that picture's, that you can see that picture on the side there. There's a test, that's actually a test block. I used to make blocks. Now I just use the cylinders. It's easier for the testers to use, but you can see how they break them and get the results we need. Amazing acoustical properties, sound transmission class of 50 to 60 plus. I believe that scale actually stops at 65 or 66 or something like that. So basically it's maxing out or redlining the sound transmission class scale, which surpasses code for multifamily residences, commercial buildings, soundproofing, make good party walls. Interesting side note, if you guys know who Randy Bachman is, of solo fame and Bachman Turner Overdrive fame, his house is built out of rammed earth and his music studio is built out of rammed earth as well. So it's good enough for him, probably good enough for most people to bang around on the drums or play whatever instrument they're playing. So some more details here. Lintels. So these are doors, window openings. If you're going to do that, we can do small openings with rebar generally, just a detail in there integrated. You don't see it, it's designed away, all good. Get into larger openings, you have to start talking about like a steel or a concrete or a wood lintel, and they can be hidden or visible depending on the strategy. It's just stuff that has to be worked out with the engineer and the client. I can't take credit for this work. This is actually somebody else's rammed earth work in both these pictures, but I tend to like the above picture. I actually haven't had the opportunity to do that style yet. Most of my stuff has been hidden, but I really like that over the rammed earth or concrete bond beam that has those little shoulders over the side. That's kind of my preferred aesthetic, and functional wise, it's nice. Window sills, this kind of is a detail you can see. They can be left just left as rammed earth in certain cases and then covered with your typical flashing detail, or we can do a high cement puddle cap and slope it to the exterior to get your drainage. This particular project, you can see actually the owner did this himself. He went and poured in place concrete sills, which is another option if you want to do that. People use lumber, kind of the same effect, metal, that sort of thing. So you can leave the window free of rammed earth and just use conventional construction as well in your windows. Basically leave gaps, as you can see in these pictures over here. Some people just leave that gap open, and rather than coming through with rammed earth after, they will do everything with conventional construction. And that's the easy, most effective way to do it as far as a rammed earth buildability standpoint. For passive house, I think we can come up with a perfect solution once start sitting down at the design table together. Some more details here. This design, the homeowner left again, what I was just talking about, conventional construction in the middle, and then you just do whatever you want to do from a conventional or passive house design. So typically we'll embed plastic lumber in the RO or a pressure treated wood sometimes. I prefer plastic lumber in this case, just to know that it's not potentially going to, it's not an organic, it's not going to rot even after, hundreds of years. I know they say pressure treated lumber lasts forever, but does it? I don't know. So plastic probably does. So we like to do like a plastic lumber, sort of a buck in there to affix your doors and windows to. And then design for, like, say for passive house, that would just be a engineering design meeting that you'd have to have. What's the most effective way to meet the performance from passive house, basically. So why build with rammed earth? So I guess the part for me that is good is that they're the most appealing part of it, especially as we'll see for passive house. It's a complete wall system. You have all the necessary control layers, water, air, vapor, thermal. It's all achieved in a properly built rammed earth wall. That's assuming you've got proper design and detailing on the other components of the building. Exterior and interior finish, insulation, electrical conduit for boxes, structure. It also reduces many other trades involvement in the project, which is nice. I'll touch on that a little bit more with passive house as we get involved. Sustainable, one knock here, honestly, is that the cement and foam-based insulation negates some of those eco-credibility points, but really they also allow for the gains, the durability, longevity, minimal waste, life cycle calculations, the materials available locally. The material that we use isn't washed like concrete is, so there's actually a fairly unknown but huge water savings in using rammed earth over concrete, because they actually wash their materials, which is a pretty big waste of water in that industry. I can use local materials and labor, and they last forever. So to me, that's the sign of a most durable or sustainable building, is that they last forever. Little side note here. I used to be into earth blocks. I used to build earth block buildings, and I'd go down to the States and work with a mentor down there. And he always used to joke that he only warranties his buildings for the first 1,000 years. So after 900 years, you better start coming after him if you want any warranty work done. So that kind of stuck with me. It's like, that's a pretty solid warranty. I haven't got any warranties that good in my life. Here's another picture that just shows the sustainability action, or the sustainability aspect of it, using the sheets in the roof as the sheathing or the decking in the roof after all the formwork was done. Usually we'll just reuse formwork over and over until it can't be used anymore. But this homeowner wanted a bit of a quicker time schedule. So we actually formed up significant portions of the house all in one shot, which used a lot more decking or a lot more sheets. But as a side benefit, then we turned around and used that as the decking in his roof. So it didn't actually add significantly to the cost of the building. Energy efficiency. This is a wall from Ontario that was being built to passive house standards. I think they're going for certification, and they've got monitors and a whole bunch of sciencey involvement on it. And so I'm hoping to follow up with them in a couple of years when the rest of the project is done. Just did the consulting and did the first couple walls with them to get them going out there. But this wall had 10 inches of rigid insulation in the middle of it. So for passive house, that's kind of the more around the angle we'd have to play at with insulation, is probably 8, 9, 10 inches of insulation, rather than just the 4 or 5 or 6 that I typically do for unpassive house builds. Airtight. I'll talk more about this in the passive house section, but this is inherently an airtight wall, which I know will make most passive house designers happy. Thermal bridging is minimized or eliminated. It's great thermal mass, which minimizes temperature fluctuations, reduces the energy use. Although at a passive level build of insulation, apparently in conversations I've had, the thermal mass becomes less of a significant factor, but it's still a bonus, still there. Rammed earth, great long-term investment. I mean, it requires almost minimal to no maintenance. It's gonna last a long time. It's durable. As long as you keep the roof and windows maintained, the foundation is solid. We're talking, hundreds, if not thousands of years. We're basically building pyramids for them, or Stonehenge for the next epoch to discover and wonder what the heck were we doing out here. Reduced energy costs. So good savings there in the long term, not so much upfront, short term, but long term investment. Aesthetics, it's beautiful, it's customizable. Each wall is unique and possesses its own characteristics. You know, we got striations, we got texture, breaks up the monotony of a simple box design house. You can simplify your design, but still get a lot of interest in a house just by playing with your wall design. Like I said, I like to consider them each wall to me is a standalone artistic piece of work. It's kind of my goal when I go into every project. Everything proof, which I say somewhat tongue in cheek. Obviously, some of these are going to be just resistant or very resistant, but insect, mold, vermin, fire, sound, bulletproof, earthquake, floods, all those basically almost proof. In this picture, this is a consulting job I did in California, near, I think it was out near Temecula actually. And this was for basically a prepper. So he was off grid. He was down in the valley in a fire zone. He had no fire protection, or he was in charge of his own fire protection. He had no fire trucks coming to him if it happened. You know, he had, I shouldn't even be talking about this, but he had like gun turrets designed into his house for like protection. He was like full on prepper mode. He was building rammed earth because he was looking for all the proofs. So he was quite happy to be able to do that. You can see he's got steel columns and a steel roof over top of it, even for fire protection on top of the already fireproofness of the rammed earth walls. So people that are looking to really brace themselves against future ifs, they tend to find some joy in rammed earth. Durability, I've kind of mentioned that multiple times. Health and wellness, big one for me. You know, non-toxic materials once the walls are cured. EMF blocking. Some people are EMF sensitive or just more concerned about those things. We get that. Really high indoor air quality in a rammed earth home. You know, you get a feeling of the natural environment. So biomimicry comes into play there, which I think is important in our environments or built environments when we're sitting inside the houses all day. Acoustic properties already talked about. Just if you've never been in a rammed earth home, it's sort of like a esoteric feeling of security and well-being. It's just a really dense, secure, comforting feeling to be in a rammed earth home. It's really, really something different actually. And one more reason, just because it's cool and you can do whatever you want with it almost. You know, if I can form it and get an idea of what you want to see aesthetically, I can probably do it. You know, I realize it's not for everyone, especially at this level of artistry, but usually once someone comes into contact with a rammed earth home or a rammed earth wall, they're usually converted to the cause. Limitations, disadvantages, cons, whatever you want to call it. I'll go through a few of those. Generally, it's not included in traditional building codes. So you're going to be fighting up against, you know, unfamiliar tradespeople, engineers, architects, designers who don't know about it, don't design to its strengths and weaknesses. You might get some pushback from people involved in your projects. Usually, to be honest, you just need an engineer's stamp. Somebody else puts their stamp on it. Most building officials just, okay, good. If you are going to be talking with building officials, I recommend usually saying it's a soil cement or a low strength concrete. And then you don't have to open up that whole can of worms of educating about what rammed earth is. It's kind of the easy button on dealing with officials that way. Some more limitations. It's not readily easy to be a renovation material. You know, it's just so heavy. You have to think about support and structure and carrying the load. So unless it's a really well-built commercial building, then maybe that's easily done. But for residents, it's kind of hard to use as renovation material. Though I do have some theories about how to do some really thin veneer panels and accomplish that. So once I can clone myself and put another guy on that full time, I'll probably have some of that coming out. You know, cement content, foam content, that might push away some of the hardcore eco purists. Planning of your mechanical systems like plumbing and electrical and all that has to be pretty well thought out in advance. Otherwise, you're pretty much stuck with what you got. It's a small building season. You know, I don't want to be building once it's getting to 5 degrees Celsius in the mornings or the nighttime, because it's just, you're talking at hoarding and heating beyond the level of just a concrete construction where you can just hoard and heat it quite simply. Maybe not simply, but you can do it, and they do it. It's kind of an industry standard in the business, isn't it, in the business? But for rammed earth, just don't do it. Or if you want, be prepared to have the budget for it, I guess, and the time. It just slows everything down. You've got to really, you got to heat everything, the aggregate piles, the cement, the everything. I consulted on a job in Ontario actually, and they wanted to build through the winter, and I expressed my thoughts on it kind of like I just did. Don't do it, don't do it, don't do it. But they wanted to do it. So I told them how they could do it. And about a month in, they really wished they hadn't done it. And they pulled the pin and said they weren't going to do it that way anymore. And they waited till spring to start up again. So like I said, small projects, yeah, can be done if the timeline is that big of a constraint and you really want to see it get done. But usually it needs to be a spring, summer, early fall sort of installation. The build time, quality takes time, just like anything. So that's a bit of a disadvantage or limitation for some, but I think it's an advantage. I mean, you're getting quality, it's going to last forever. Complex designs, or when you really want to start pushing the aesthetic envelope, or round walls or tall walls, curved walls, it can get costly fairly quickly. But if you stay to recommended design parameters, it's possible to keep it a little bit more reasonable. The other disadvantage is people are going to be insanely jealous of you having the nicest walls in town. So you got to deal with envy and jealousy. There's a nice little quote I like. So when you build a beautiful building, people love it. And the most sustainable building in the world is the one that's loved, because it's not getting torn down or renovated or forgot about or neglected. So now we'll move on to Round Earth in the context of Passive House.
So do you provide engineer stamps for the drawings that you do, or for the planning?
I don't have an in-house engineer yet, but I do have a couple of engineers that I like to work with or farm that out to, or, you know, basically have consulting engineers that can work with your preferred engineer or local engineer that you would like to work with, and kind of guide you through that process to, I guess, comfort the engineer that is going to put their stamp on it. Or in Alberta, the engineer I work with, they do maintain an Alberta engineering license. So that is a possibility for your locale.
And how thin are the rammed earth walls?
So
how thick or thin should they be?
So for an interior wall without insulation, technically 8 inches would be the minimum. Personally, my preference is more like 10 or 12, just for ease and buildability. Going thicker doesn't actually add much more to the cost at all. It's just more sand and gravel and a bit of cement. So, you know, I like to say 10, 12. I could do 8 if I had to. 16 has been done before. When we're talking insulated exterior walls, thermal envelope, you're starting at about 18 upwards of 24 to 26 inches. And that would have like 8 inches of earth, 10 inches of insulation, 8 inches of earth on the upper end.
The other last question, Stuart, is about the durability in a wet climate. So what happens in coastal weather?
They actually, because of the admixture, they're great for the wet coast. Actually, most of the rammed earth building in Canada is actually done on Vancouver Island and in Vancouver on the coast of BC. The more well-known rammed earth builder, Sirewall, they kind of brought this into the modern age with the insulation and that sort of thing. All their houses are built in like Salt Spring, Gabriola, all over the island. So you don't get much more coastal and wet climate than that. And they perform spectacularly.
That was my question. And they would also mitigate indoor humidity changes too, right?
Exactly. So again, there's a bit of I used to say, oh yeah, they're perfect thermal and humidity regulators. And a lot of people say that. The reality is that's when we're talking about raw rammed earth with the clay. We do use cement, so you give up some of those hygroscopic characteristics, but from my understanding of the research I've read, there is still a benefit to it. It's just not as pronounced as, say, a raw rammed earth wall would be. It's not
much better than a typical constructed wall.
Exactly.
Yeah.
So now we'll move on to rammed earth in the context of passive house. I've worked on a number of passive house builds in between rammed earth projects. I've been fortunate enough to fall into a number of passive house builds locally, because there's not a lot of people interested in that sort of thing around here. And being a rammed earth builder, I'm naturally just familiar or crazy enough to want to do these outside the box thinking and design. So I have worked on 3 or 4 builds. I'm actually building one right now for a builder outside of town here right now. Kind of took on that project. I've been on the insulator, actually packing in silos all week. So this is kind of a nice break to be talking and sitting rather than running an insulating machine. Some overlap here from the previous, so maybe I'll speed up a little bit, but it's a simplified wall system. You know, passive house, you're trying to achieve that performance with framing and sheathing and taping and more framing and meshing and membraning and taping and insulating and more taping. And did I mention taping yet? Can you tell what I've been doing for the last couple of weeks? A lot of nothing that $50 for the tape can't fix. Thanks, Siga. So I'm always thinking about how a round earth wall system would be a good thermal envelope. You know, you get all the functions you need: load bearing, finishes, insulation, weather resistance, all your barriers, moisture management. We just talked about aesthetics. It's all one process. It's a natural low tech material, lasts almost forever. Obviously, I'm more than a little biased, but it's a no brainer for me. If I was going to build a passive house for myself tomorrow, I would be looking at rammed earth because it just seems like the simple way forward. It's not going to be for every project, obviously, but I think it's definitely should be a consideration for a lot of them. Airtight, energy efficiency. You guys really like blower door tests, so passive house, you know, it's inherently an earth. It's a 2-foot thick wall. It's you're not getting air through there. Plus, there's rigid insulation in the middle. I saw a round earth house or a round earth passive house in Texas received or achieved a 0.33 air changes per hour at 50 pascals, which seems pretty decent to me. Efficiency, energy efficiency. I know large cube or rectangular minimal corners is the most passive house design. Rammed earthers really like that design as well because it's simple to build. So that kind of plays into our favor as well. So we get some building efficiency there and cost efficiency and energy efficiency all in one. Minimal, no thermal bridging, you got to insulation, all those sorts of things, thermal mass, for better or worse. How much it contributes to a passive house at that point is questionable, but you basically have to do more natural, eco-conscious building materials to a passive house performance is what I like about it. Sustainability, you know, reducing a lot of those high-tech materials and lumber that a conventional passive house requires. That'll be appealing to some clienteles that, you know, still want to focus more on materials and not just energy efficiency or performance. I can use rock wool, rigid rock wool in the middle instead of foam-based products, which is nice. Beauty, high performance. Don't think I really need to go too much more into that. It's pretty obvious that it's beautiful. For, you know, some people might not think so, but most people, when they see it, they think it's pretty beautiful, and I can customize it to what you want. Natural element. And beyond just a thermal envelope, you can use them as feature walls and just improve your aesthetics in what might otherwise be a simpler design for improved energy efficiency. You can kind of mitigate some of the plainness, we'll call it, of some designs. Make great multifamily residence walls, you know, soundproofing. I talked to one passive house guy who thought it was a great idea to just build the thermal envelope and divide up the interior with conventional framing, however you want us to do. Here's a nice one. It reduces or eliminates a lot of the other trade involvement. So I don't know if Alberta is probably in a similar situation as Saskatchewan, but it's getting difficult to line up trades and get them there when you need it to be done. This picture shows, you know, I'm doing electrical conduits in the wall, boxes. To be honest, I prefer not to do that. So if you can make those disappear in the floor or the internal conventional wall, so I don't have to do that, it's obviously easier for me, but it can be done, and I do it all the time. So it's not to say I won't do it, but it's just one extra step. But that's also one less thing the electrician has to do. He just has to come and pull his wires after the fact, and they love it. Plumbing, we try and not run it in the walls. If we're going to run plumbing, we'll run conduit, like steel conduit pipe in there, and then you can pull your PEX through that, so rather than just running pipe in the walls for many obvious reasons. Drywalls, tapers, painters are all basically eliminated or at least greatly reduced. The siding guy, he can just stay at home and watch TV because he's not needed. Or if he is, I don't want to know about it. So that's a nice benefit. You know, you're reducing it, a lot of other trades. Limitations, the physical footprint is quite significant of a rammed earth wall already. So when you start thinking about R40 or R50 insulation, which you can reach with a 10 inches of rigid insulation in there, you're starting to get into that 2-foot plus thick wall. You can always go more, but then it becomes a design and a footprint issue. Your beautiful pressure treated wood foundations are probably out of the question. We're going to need concrete under there. It's just so heavy and the pressures are involved. You're going to require concrete, so no pressure treated wood. Cost, with that much rigid insulation, that's going to be a factor. And you're basically piling up two cost premiums. You know, round earthers and passive house people always like to say, well, there's not much of a premium for passive house. So there's not much of a premium for round earth, but quite often there is. Not always, but often it does happen. So you can potentially be carrying two premium prices, but some of those will neutralize each other with efficiencies and that sort of thing. And if architects and designers understand the process and also bring in a round earth consultant early on, you can design to the eccentricities and the dimensions of formwork and that sort of thing, and reusability of formwork to save time and save money and that sort of thing, to help the design from the get-go, rather than trying to impose a rammed earth building onto a not rammed earth design. Because it's a different from concrete and other building material, we have a bit of a process. I'm going to go through this pretty quick to save time. If anyone wants to, and by means, if anyone wants to reach out and go into any of this in more detail that I can't do today, reach out. I love to talk to people. I'm all about getting out the rammed earth propaganda because not many people know about it. So our process, the original discussions and plan assessment, that's where I was talking, make sure the round earth guy is involved so you can save some time and energy that way. Preliminary mix design consulting package, that's when we will start looking at, soil selection, aesthetics, casting some samples, making sure the strength is there, getting aesthetic approval, doing a mock-up panel as necessary, or even a mock-up wall, depending on the designer, design feasibility and value engineering. Construction process becomes, forming, mixing and ramming, stripping, letting the walls cure, and then if necessary, not always necessary, a bit of a clean and sealing. And that's more for high traffic commercial areas or people that just want to make their walls as long-term bulletproof as possible. You don't really need the sealing, but it makes them a little more dust proof. It makes them a little more waterproof, even though they essentially are waterproof already. It's just kind of is like the final touch that you can do, but 9 out of 10 people don't actually do that step, but I'm starting to recommend it especially for commercial and high traffic instances. You can see the aesthetic process here, just sample blocks showing that sort of thing, the process. Cost, generally, I don't talk too much about cost because it basically depends. But for a rough starting point, if you want to think for most buildings that are not too complicated and crazy, think about $150 a square face foot. That's kind of a good starting point. It might be less for a simple design, a perfect site and a simple geometry and low heights and that stuff. But that's a good number to have in your head. Just to
that's an insulated wall, Stuart.
And that's an insulated wall. Yes, yeah. Exactly. Okay. So that's a good place to start off with. It can, for an uninsulated wall, it can start going down. As I said, simple designs, it goes down. But it's pretty easy to start climbing as well. You start going tall walls, curved walls, more involved aesthetics, remote sites, restrictions on the site, that sort of thing. It's easy to get up to $200 plus a square face foot, and especially nowadays with everything going up in price. But there's a lot of long-term value, like we talked about. So reduce maintenance costs in the life cycle. So I like to think it's more affordable over the long term, but most people want to know, what does it cost me today? Goals for passive house and rammed earth. I just want to open up the lines of communication, get out there, let people know what it's possible, hopefully get some interest to see if I can't help you build your high performance walls, but prettier essentially, and with, simpler walls and less ingredients in the mix. So yeah, if anyone's interested, reach out.
A couple of questions for you, Stuart.
Yeah.
Can it be used below grade and safe for walk-up basement?
Yes, people do it a lot. If it's going to be, you're going to lose some of the visibility on the one side. So sometimes I say, why not just use concrete? If you're going to lose the exterior finish, if it's backfilled, but if you really want to see it in the interior finish, yes, we can do it. You can put membranes or coatings on it to make it suitable for below grade. It just becomes an engineering detail as far as rebar and cement content and that sort of thing.
And can it be used as a retaining wall? Same answer, I'm going to guess,
And
right?
again, that just becomes an engineering question. Yeah, it just, I'm not going to do the calculations on it. I'm going to farm it out to an engineer or go by what your engineer says. But yeah, it just becomes about bracing and, tiebacks and all of that.
So it just needs to be engineered.
Exactly.
Right? Okay.
And if anybody, like I said, reach out, email, phone me, send me a text, whatever. I'm happy to talk all day, any day about this. As you can tell, I got, I think I got through most things. I'll toggle through here. Window infills, like recessed electrical box that shows a thin wall, how tight it gets. That's about a 16 to 14 inch wall. So you can see as you get you're telling that 8, 10, 12 inch wall, how much harder it is to ram in. This is the hydrophobic admixture and not. In one wall, you can see that it's just running off and it's dry in a half an hour, and the other wall, it's just soaking in like a sponge. Just I'll skip that. That's too detailed for this, but yeah, of course. I think I can leave it there for you. Like I said, I could go on for hours if I had to. There's my contact info, and I also have a little bit of a PDF one pager if people want it, if it's interesting for them, or if you need even like a sample block because you have an interested client or something that you really want to get your hands on it and touch, reach out. I could knock out a quick sample product for texture and aesthetic visual purposes for you if the case presents itself.
Thank you very much for all this. I really appreciate it. Thank you everybody else for attending.
Yeah, thanks everybody. Appreciate your time.
Meeting today has been recorded, so it should be available on our website sometime in the near future.
Awesome. I look forward to seeing that.
Thank you.
All right,
and there's a thanks in the chat, Stuart, from Sean and Bonnie. Thank you. And
thanks, guys. Thanks for being here.
Beautiful walls.
All right. Thank you very much. Take care, everyone.
Thank you.
You're welcome.